Good morning, everyone. Welcome to day 2 of MDIS. My name is Carlos. I am a member of the Excel engineering team.
Hi, I'm Urmi. I'm a member of the Excel engineering team, and I work alongside Carlos.
So Urmi and I were reflecting the other day just how an amazing moment it is today to be a data professional. If you see the breadth and depth of sessions available at this conference, you quickly realize that there's a lot to learn and a lot to absorb. So we really appreciate you choosing to spend an hour of your time with us this morning. Now, I might be a little bit biased because I work in the Excel team, but I love Excel. And it makes me really happy. It gives me a lot of energy to come here first thing in the morning to talk about Excel and forecasting with a few hundred friends. Now, we have a lot of content to cover today, so we might not end up having a Q&A session, but both Urmi and I will stick around, so you can approach the stage if you have any questions, or we might be right outside. And you can always reach out to us via Urmi's email, and in my case, via Twitter. I'm active on Twitter, so if that works for you, you can reach out and continue the conversation there. Clicker. Cool. So there's 3 reasons why we think talking about Excel and forecasting is important. The first reason is if you think about forecasting, right, it's such a critical business process. All sorts of companies of all shapes, sizes, and from all sorts of geographies have forecasting as a critical business process. Then if you look within the companies, right, you can have multiple different disciplines and departments running forecasting processes. You could have a finance department, for example, forecasting COGS. You perhaps could have a sales department or a marketing department forecasting revenue or quota attainment. Or you could even have an engineering department, like the one Urmi and I work in for the Excel engineering team, forecasting dev hours or forecasting bug attainment rates. So critical business process. The second piece is, if you think about critical business data, if you think about critical business workflows, at some point or another, they either live in Excel or they go through Excel. We see this time and time again when we talk to customers, when we do user research. It doesn't matter the environment that the customer has. It doesn't matter what other BI tools they have alongside. They always use Excel alongside these BI tools. So in some ways, you can think of Excel as the most widely used business analytics tool in the world. And this brings me to my last point here. If you think about the forecasting techniques, tools, and technologies that you use, or that the industry uses, there's been a lot of development and change in the last few years. You see this in the increasing importance of fields like data science. You see this in the increasing importance, size, and complexity of data. Data is really everywhere. And this, in a way, adds a lot of pressure to data professionals like yourselves to make sense of it all. So one of the key goals that we have today is to share a few tips, a few techniques, and some advice that hopefully will trigger something when you go back home that will make improve your Excel skill sets and perhaps make some of your forecasting processes more efficient. Now here's the plan for today. We're going to talk a little bit about forecasting techniques, and we'll also cover some forecasting processes. The first thing from a techniques perspective, we'll start relatively simple, and we'll share a forecast using averages. Then we'll talk about a technique called exponential smoothing, which is a technique used for time series forecast. And we'll show you how you can easily do this in Excel. After that, connecting back to the point I made earlier about data science, we'll share how you can start integrating some data science workflows into your Excel workflows. One of the tools that we've picked for this is called Azure Machine Learning. And within that framework, we've picked a programming language called R, which is a popular programming language for data science, as well as a particular technique called ARIMA. The last thing we'll share here is an industry calculation called MAPI, which is used to compare the forecast accuracy of different calculations and different forecasts. There's 2 things I need to clarify here before moving forward. One is neither Urmi or I are data scientists, and we won't pretend to be data scientists for today. What that means is that we won't go into a lot of depth on the technical aspects of these techniques. That said, the deck has several resources. There's several links in the PowerPoint presentation, and all of these resources will be made available after the presentation. Also, there's several sessions at the conference that go much deeper on the technical aspects of data science and data science workflows. So if anyone is interested in learning more about that, I would highly recommend going to those sessions. Of course, all the recordings are going to be made available as well afterwards, so you can reach out and look at those online. The second piece here is that Urmi and I have spent the last few weeks actually talking to forecast professionals at Microsoft. So we've reached out to a bunch of different teams. We've talked to the credit and collections team in the Fort Lauderdale office. We've talked to the office finance team in Redmond. We'll talk to the treasury team. A variety of different teams and experts that have forecasting as a critical part of their job. So this is to say that all of the examples that we're showing today are actually anchored on real examples and real scenarios. So everything we're showing today, we've captured from our conversations with experts. Now, one of the themes that has emerged when we were talking to all these people internally at Microsoft is that forecasting is very much, of course, about crafting the forecast, but also about the forecasting process. And this is especially important in large, complicated companies where you might have multiple subsidiaries, where you might have multiple departments, all of them submitting different forecasts. So as a bonus tip, it's not really a forecasting technique, but as a bonus tip, we'll share one idea on how you can start aggregating forecasts from different teams if you have such an environment in your company using some modern tools in Excel. Now, to tie everything in a nice little story, we're going to pretend to be a bike shop today. In this bike shop, we're going to have 4 analysts. We're going to have 3 analysts that will craft their forecast using the techniques that we talked about earlier. So we'll have the repairs analyst doing a forecast using averages. We'll have the accessories analyst doing a forecast using the exponential smoothing technique. And we'll have the bikes analyst doing the forecast using ARIMA and Azure ML. Now, at the end, we'll have a poor soul and Corp HQ whose sole responsibility is to aggregate this all. And now, it's a little side story. Many, many years ago, before I joined the engineering team, I myself used to be a data professional and used to work in the finance department at Microsoft. So this analyst here is in a way based under my experience. So that was my role, aggregating the corporate forecast and budget for the worldwide revenue process for Microsoft. So let's jump right into the first demo. And here thank you. Here we'll look at the repairs analyst. And this analyst will generate the forecast using the averages technique. So the very first thing, before I jump in, let me orient you to the data set that I have here. And this will be consistent throughout. So I have a time series, essentially, going from January 2013 all the way to December 2016. So I have 4 years of actual results. And then I'm going to forecast 2 years down here, from January 2017 to December of 2018, right? And then in this column here, I have my actual revenue that already happened. So this is the repairs revenue. Now, the very first thing that we observe the analysts at Microsoft doing and the different experts that we spoke with is charting the data and getting a sense for the shape of the data. And this, in a way, will inform what technique you end up using. In this particular case, I don't see any seasonality or any interesting trends that would lead me to want to use a different technique. And in this case, this analyst used this averages technique, and it has worked well for them in the past. And it's relatively straightforward. So down here, I have this function that's already pre-populated. And what it's doing is just taking the average of the historical January months in the past. All right, so I will insert this here. I will drag this down. And then if I go back up, I can see here my chart, right? In blue, I can see my actual results. And in orange, I can see my forecast results. And again, if you look at the data, you just get a sense for the shape. This looks relatively reasonable. The analyst is not expecting any surprises. The repairs business is relatively stable. So she will go with this forecast. Now, going back to the Corp HQ analyst that we talked about, this person has set up a process for her colleagues to follow, right? And in this process, she's asked for a template to be submitted. And this template essentially has 3 columns. It has whether it's an actual or a forecast, each of the months, the actual date, and then the revenue. And in just one column, both the revenue and the forecast. And she's also requested that this file be submitted to a team share. So the repairs analysts, once they're done, they will drop that file in this share, and then they will be done with this process. Now let's go back to the exponential smoothing technique.
Thanks, Carlos. Now let's discuss the exponential smoothing technique, which is the go-to technique of choice for our accessories analyst. Exponential smoothing, or ETS, uses the weighted mean of past values. One reason ETS is so popular is it adjusts for seasonality in data trends. Some trace the origins of the technique back to Poisson in the 17th century with his numerical analysis techniques. And in the 1940s and beyond, this was made more popular by the signal processing and then telco communities. In Excel, we use the Holt-Winters ETS algorithm. In Excel 2016, we introduce native ETS functionality. There are a few new functions, such as forecast.ets, as well as other supporting functions which provide additional supporting statistics. These functions will handle up to 30% missing data in forecasting. On the Data tab of the Excel ribbon, we have introduced a new feature called one-click forecasting. With that feature, you can create a nice chart visual. The blue line shows the actual data, and the bold orange line shows the forecasted data. The thin orange lines above and below it show the upper and lower confidence bounds. We'll go into this in more depth in the demo.
Thanks, Hermie. So let's jump to the second analyst here, the accessories analyst. And I'm going to open their Excel file. And again, very similar structure here. I have my dates going from 2013 to 2016, and my actual revenue, my historical revenue. And again, I'm going to forecast out 2 years of monthly data. Now in this case, again, the very first thing this analyst is going to do is to plot the data. And in this case, it's very clear that there is a seasonal pattern. If I look at these spikes, they always happen between October and November of every year. And the shape of the data is very consistent. So this analyst also, like Urmi said, recently attended an Excel conference very much like this one and learned about this new technique called exponential smoothing and the fact that Excel now has this technique. And she thinks that this technique might be a good candidate to help her with the forecast here. However, she wasn't paying attention. She doesn't really remember where the Excel team decided to hide this feature, right? So it's like, what am I going to do now? That said, she does remember one new feature that we added, which is this tell me bar up here. So she doesn't need to go fishing around to find this feature. All she needs to do is select her historical data, the month and the actual columns, go up here to this tell me bar, and start typing forecast. Now, the very first option that comes up is the forecast sheet that Urmi mentioned that automatically, with one click, will run the exponential smoothing technique. So let's do that. So I click on that, and this right away runs the technique on the actuals. It's plotting the actuals right here, like Urmi mentioned, and then right here in the orange, I have the forecast. I also have a few different bells and whistles down here, which I don't need for this scenario, but of course, you have some more options, including some supporting statistics that you can output as well. So now if I click the Create button, what this is going to do is it's going to insert a new sheet. It's going to insert an actual Excel chart already hooked into your data and your forecast. And more importantly, if you scroll down here, it's going to insert the forecast.ets function automatically hooked up in the correct way to generate your forecast. So the cool thing about this is that if you need to go in here, for example, if you know there's going to be some sort of promotion or some sort of deal in a particular month, since this is now an Excel function in the grid, you can go and leverage the flexibility of Excel and adjust that, add any more logic, and run your forecast that way. Now, let me go back to this tell me feature. I really love this because I'm one of those people that try to avoid using the mouse as the plague when using Excel. I'm pretty proud of the collection of keyboard shortcuts I've collected over the years, but especially for new features, I can't really remember some of the new keyboard shortcuts. So this is just a little tip. The new Tell Me feature, if you click Alt-Q, that's the keyboard shortcut for the Tell Me feature. It will put the cursor up here in the Tell Me bar. And then you don't need to memorize any more shortcuts, because you can essentially type anything, right? If you want to do conditional, come on, why is my cursor not working? Conditional formatting, for example, right? And it goes directly to the command, and you can use natural language. It's really fantastic. All right, so once the analyst feels good about this forecast, right, like we said, you look at the shape of the forecast, and it looks like it's mimicking the seasonality. You can see that it's recreating the spikes in October and November. Once she feels good about this forecast, she will again populate the template that the Corp HQ analyst has requested and drop that in the share where all the other forecasts are being aggregated.
Thanks, Carlos. Now, let's discuss the technique used by our bikes analyst. Our bikes analyst is enthusiastic about machine learning in general and chooses to use a tool called Azure Machine Learning Studio, or ML Studio for short, along with R and ARIMA. Among the tools used by data scientists, R and Python feature prominently, as you may expect, as does Excel. In our conversations with data scientists and analysts, we've heard time and time again that a pain point is how to integrate into Excel. One way to solve this is via Azure Machine Learning. This tool is a cloud-based predictive analytics service that makes it possible to quickly create and deploy predictive models as solutions. With ML Studio and Excel, we bridge the gap between data scientists and analysts. We can start with a data set, bring it into ML Studio, deploy a web service, and then make the data ready for consumption in Excel via a free add-in called the Excel Azure ML add-in. Machine Learning Studio is the tool of choice to experience Azure ML. It's a cloud-based IDE for ML, and it offers the one-click deployment of web services. The tool also supports advanced analytics via R, Python, and other packaged modules. If you are an advanced user of R and Python, you can use your IDE of choice, such as RStudio. However, if, like us, you're newer to data science and machine learning, the drag-and-drop nature of ML Studio is appealing. In ML Studio, you can create your own experiments, run them, deploy a web service to make them available to other applications, and then share your experiments on the Cortana Intelligence Gallery. Let's have a quick look at this with a brief introduction. Over here, we've created a little experiment with just 4 components. It's called the AutoRima experiment. We can enter data manually in this experiment, or via a web service input, run an R script of our choice, and then have the data output via a web service. For our R script, we chose to use the forecast package, and over here we call the AutoArima function for forecasting. Once we've designed the experiment we want, we can run the experiment, deploy a web service to make it available to Excel and other applications, and we may even publish and share the experiment on the Cortana Intelligence Gallery. And over here, we've chosen to do that. We've got it published here. Cortana Intelligence Gallery is a place you can go to find other related experiments. You can browse and search for related experiments. So ML Studio is great to make data science more accessible to many of us.
Great. Thank you, Rumi. Oh, no, there's still more. Yes.
Still more, sorry.
That's okay. There's more. Yes.
For the R forecast package that we had a look at, we can leverage that in ML Studio, and that makes functions such as Autoarima more accessible. ARIMA stands for Autoregressive Integrated Moving Averages. It's used for time-based data series predictions. Some ARIMA functions are good for statistically stationary data, and some are good for handling seasonal variation. ARIMA models can be estimated using the Box-Jenkins approach. In ML Studio, besides the R forecast package, we have several other powerful packages for different domains and apps. Now over to you, Carlos.
So great, thank you, Urmi. Let's now look at the third analyst, which is our bikes analyst. And this analyst has not only gone to the Excel conference that the accessories analyst attended, but she's also gone to a data science conference and started learning about some data science techniques and some more advanced tools. One of the tools that she's learned about is this calculation called mapping. And by the way, like I don't really know why anyone needs PowerPoint if you can have slides in Excel. So that's what I'm gonna, right? So that's what I'm gonna go with. So she's learned about this technique called MAPI, right? And MAPI is a tool, it's an industry calculation used to compare the forecast accuracy of different forecasts. MAPI stands for mean absolute percent error. And essentially what it is relatively straightforward. Essentially what it is the percentage delta between your forecast and your actuals. So you're forecasting for a period that already happened, so you're going back retroactively. You take the absolute percentage difference, and you average that across a number of periods, a number of months. And of course, a lower MAPI is preferable. Let's just do a little example here. So I have 4 months of actual data. You can see my actual results are right here, and my forecast is right here. So for each of these, I'm going to take the delta between my actual result and my forecast. Then I'm going to divide that by the actual, and then I'm going to take the absolute number. Right? Because in a way, it doesn't really matter if you're 5% above or 5% below, right? You're still 5% off your results. And then I'm going to take an average down here. So it's pretty straightforward, but again, going back to what I mentioned earlier, we've actually seen this being used internally at Microsoft by the forecast teams in the finance department just to compare different forecasts and adjust what they do. We've also learned that around 5% is what usually they try to aim. Of course, 0 would be ideal, but that clearly is unreasonable. All right, so what this analyst is going to do is compare different techniques, right, and use MAPI to pick the best technique for her forecast. So in this case, it's the same exact structure. So I have my date column here, my bikes revenue here, so this is the bikes analyst. And I have actuals going from January of 2013, actually from January 2013 all the way to December 2016. These are all actual results. And I'm going to go back 1 year and forecast that year and compare the accuracy of different techniques. And we're going to do all the techniques that we've learned today. The first one is the averages, right? So I've already inserted this here. It's the exact same thing, going back historical months and calculating that. And I've already pre-populated the MAPI over here, and I'm getting a 10.9%. So not bad, but I think we can do better. So then I'm going to use the forecast.ets technique. And in this case, this analyst is a little bit more advanced and feels more comfortable inserting the function directly in the grid. But you can always use the one-click forecast technique that we showed you as well. So I've pre-populated this function over here. If I add the equal sign here, you can see the references lighting up. So I need to pass in the month that I'm forecasting, the historical monthly rate range, and the historical actual range. And then if I drag that down, I've already calculated my MAPI over here. Again, let me just show you how this is done. It's the exact same way, the delta. And if I take the average, it's 7.5, which is better. But this analyst thinks they can do better even than this. So again, she learned about, in this data science conference, she learned about Azure ML and ARIMA and R, and she's going to use the web service that Urmi showed you earlier. So the way you do this within Excel is you go to the Insert tab, and you use the Azure ML add-in for Excel, which is a free add-in that is available through the Office store. In my case, I have used it in the past, so it's in my recently used list here. So I will launch the Azure ML add-in, and this will launch a side pane. And in here, I will see that I have 2 different web services available for me that I have created in the Azure ML Studio and made available to the add-in. I have an Autoregressive function and a Holt Winters function. I'm going to use the Autoregressive for this particular scenario. It's going to ask for some information. My input range is the same in column B, and my output range is over here. I have a little spot that I've selected for my output range. Now, when I click Predict, if the internet works, yes, great. If I click Predict, what this is doing is taking the data from Excel, sending it to the Azure cloud, running the calculation, and bringing it back. Now, in our case, we have a simple ARIMA function, just to illustrate. But it really could be anything, right? You really could run any arbitrary R code, any arbitrary Python code. We saw some pretty sophisticated capabilities being used by the finance team internally at Microsoft. And in fact, in one of the techniques that we saw from the Fort Lauderdale team, they were running the MAPI in R. So they were doing all sorts of calculations in R. They had a bunch of different techniques in R, and they were comparing the accuracy in R and then spitting back the result in Excel to use in their workflow. So in this case, I'm going to point to my Azure ML output here, just to have the same format. I'm going to drag this down. Oh, hold on. Oh yeah, I have an issue here. I think I don't need the headers. Let me try this again. There we go. I had, no. What did I do wrong here? M37. Let me try this again here. Where did Excel go? Come on, let me try this again. So I'm going to select my historical data here. Good. M37. Something is a little off here. Oh, okay, so let's see what's happening. My range is a little off here. There we go. There's something off here. Apologize for that. But this is the result I was expecting. So now I have my output back in Excel, and I can see that my MAPI is 5.9, which, getting closer to that target of 5% that we were going for. Now, if I run the actual forecast, and in this tab, I have already previously run the forecast on the actual period that I want to forecast out for 2 months, I can see again that it's picking up the seasonality, and the shape looks nice, and it feels right. So once this analyst feels comfortable with this forecast, they will, again, populate the template that the Corp HQ analyst has requested, and then drop this back in the file share that the Corp HQ analyst has requested.
Thank you, Carlos. And there was some great real-time debugging as well. Make it real for Excel. It's a great programming tool, right? So now we turn our attention back to our analyst at corporate headquarters, who has the fun task of bringing in all the data from the various divisions that Carlos showed into Excel to make it more meaningful and compare and contrast things. And the tool of choice is get and transform. With get and transform, we can create repeatable, automatable, and auditable queries and transformations. We can easily get our data into Excel, combine it from various data sources, and then clean and shape it for analysis. Get and transform is available in the data part of the Excel ribbon. The feature is built into Excel 2016 and Power BI. It's also available as a free add-in, a free Power Query add-in in prior versions of Excel. Now let's do a quick demo of this feature.
Thank you, Urmi. OK, back to our last analyst here. And for this demo, I'm going to start with a blank Excel sheet. And going back to my share that I've asked all my colleagues to populate with their templates, I can see that they have all followed my instructions, so this makes me really happy. So I can see a repairs file, an accessories file, and a bikes file, which is what I'm expecting. So now if I go to Excel, and let me minimize this guy. If I go to Excel, I need to aggregate these all into a report. And again, this is something that we've seen time and time again when when we talk to the different business teams at Microsoft. It's a real pain point, especially when you have to do this every month, every quarter. And we've seen people doing this manually in the past. We've seen people having all sorts of crazy VBA to aggregate and automate this process. Now there's a better way of doing this with modern tools available in Excel. So all I need to do is go to my Data tab. Like Urmi mentioned, there's a new Get and Transform experience that's been built in Excel 2016 as the default way of bringing data and cleaning data in Excel. If I go to the Data tab, I can see there's a number of different data sources that I can pull data from. And this is one of the key things about this feature, both in Excel and in Power BI. A key part of the investment is bringing in every month, every quarter, new connectors, new ways of bringing data into both Excel and Power BI. For this case, I'm going to point to a folder. And just because I didn't know how the internet was going to work, I'm pointing to a local folder. But it could very well be up in SharePoint or OneDrive as well. But just to make our lives easier, to be safe, I'm pointing to a local folder. So if I click Browse here, I need to point to the folder where my forecasts are, Bike Shop Forecast. So I can see the path there. And then if I click OK, this is going to go into that folder, scan that folder, and show me the files that it finds. So I can clearly see a file for repairs, a file for accessories, and a file for bikes. Now I have a few different options here, but they're pretty self-explanatory. I want to combine the files into one table. And then if I open this drop-down, I have a few different options, right? If I know that the data is clean and ready to go, I can click Combine and Load, and this will give me some options to load it into the grid for analysis. But I actually know I want to clean up this data a little bit, and I want to record some cleaning steps. So I'm going to click Combine and Edit here. What this is going to do is going to run the Power Query engine, and is going to go into the files and understand the file structure a little bit more. And it's telling me, hey, here are the tabs and the different tables that are available in these files. I know that the template is in the forecast template, because that's what I named it. And then I can see a little preview of the data in here. So this looks pretty good. I can see the actuals and the forecast. Now I'm going to click OK. Now that engine is going to kick in and actually bring all of the data from those files into Excel. Now in this case, I have 3 files, right? And it's not a lot of data. But I worked on a demo for a presentation a few weeks ago where we had 100 million rows of data. This was for the Surface release a few weeks ago. And it will run just as well. I mean, it will take a little longer, but you can aggregate hundreds, thousands of files in the same way. So now here, this is the editing experience for Get and Transform and for Power Query. So just to orient you here, in the process of doing the combine step, it has automatically created a few different queries that automate the process of combining all of those files. Now over here on the right, I have the data, and if I scroll down, I can see the repairs, and now I see accessories. I keep going, I can see the bikes. So now it's all been combined into one nice table for me to work with. Now there's a few cool tricks and cool new features that we've added to Get and Transform recently. The first one is this feature called column from example. So I can see this column still has the file extension, and I don't really want that. I just want to have a clean department's name so I can build a pivot table and some slicers off of that. So I'm going to select this column, going to go here to from example, from selection, and now I can start typing the data that I want to extract this column, and that's going to pick up the pattern. I think this is really cool. So if I start typing repairs, and I click enter, it has automatically detected this pattern. And if you scroll down, you'll see that I don't have to type in accessories. It automatically detects that pattern and applies it throughout. So if I click OK, it's going to add a column, and now it's a nice clean column. I can delete this old column because I don't need that. I will rename this to department. Then the next thing I want to do is, given this is monthly data, and each of the dates really starts on the first of the month, I really want to break this out into a month field and a year field. So again, so I can have more granularity on my pivot table or my report to slice and dice. So if I go to transform, there is a feature called split column, and I will pick by delimiter. And the engine is smart enough to detect the pattern. That's the delimiter. All I need to do is click OK, and it will automatically break it down into 3 columns. So now I have a month column, and I'll name it as such. I don't need the day column. That's really useless at this point. And then I have a year column. Now, the very last thing I need to do is change this to be a currency. There we go. Now, the last thing I'll point out, I mean, and there's all sorts of different techniques and capabilities. One of my favorite ones is this one here, unpivot. Have you ever tried to manage data so that you can bring it into a shape where you can use it in a pivot table? This is the tool for you. Just that button alone has saved me a lot of time. The last thing I'll mention here is here on the right-hand side, all of these transformations that I've been working on are automatically recorded for me. So I can go back in time, and I can see the state of the data as of any of those stages, right? So you can record, you can audit what your colleague did before. It's just a fantastic tool. And the other thing is, this analyst has to do this process every month, right? So once that they've set up this process and added the cleaning steps, they can just click refresh and it will do it again every month, right? So now that I'm done with this, I can go here to close and load. And if I do the second option, it's going to give me a few different options here. Let's give it a second. Something happened over here. There we go. I actually want to create a pivot chart in a new worksheet. I'm going to click OK. And now the engine is running. It's applying all those steps, and it's going to bring the data into the grid. I see that I have 216 rows that have been loaded. Let me close this and expand this so you can see this a little bit better. So up here in my bike shop's forecast, I have all of the fields that I have been playing around with and get them transformed. I will pull my revenue to the values field, and I can see that I have historical sales of close to $1 million. And then, if I remember this correctly, I want to bring the year to axis so I can see the trend. If I bring department to the legend, I can see the breakdown by the different departments. And if I bring my type, I think over here, down here, there we go. So that's kind of what I want to do. So now I have all the data sets aggregated into one report, month after month. I can click the refresh button, and this will recreate the steps, saving me a lot of time and headaches. Back to the deck.
Thank you for joining us bright and early this morning. So with this talk, you can certainly reach us for more questions on the Twitter or via email. We will also hang around the stage for any more questions. Please feel free to come and chat with us. We'd love to learn more about your scenarios. And at the end of this deck, there are slides on several other resources, such as Excel resources, pointers to other sessions that may be of interest, and then additional resources to learn more about forecasting. Thank you, and please enjoy the rest of the conference.